Good, fantastic. Okay, all right. So let's begin. Hope you guys are able to hear me. I'm audible to everyone.
Yes.
Okay, okay. Thank you very
Yes.
much, guys. So let me just share the screen and we are going to begin right away. Okay. So these are my slide sets. Why it is not shared? Yeah, it's already shared. Okay, is it? Okay. Okay. All right. So this particular uh, topic which we are going to begin is it's going to be introduction to the Linux device drivers. Now what happens most of the things if you see I have covered as a part of the inner circle meetup. I have also covered it as a part of webinar, but we are going to go in a structured way. So it would be a kind of repetition for you. That's perfectly fine. So we are going to go in a very structured way in this particular live session. So even if there is a kind of refresher for you, please bear with everyone. So everyone might not be knowing the things. So for everyone's knowledge, I would be refreshing some of the concepts which we would have discussed in the webinar. Okay, so before we begin, let me just remind you what we are getting into and what all things does it contain. Okay, so first of all, as I have been telling, this particular thing which you are getting into, it's not a course, it's a journey. So that's why, see, if I would have considered it as a normal course, my idea would have been something like this: complete it within a matter of 2 days. The various other institutes are doing like this. You see, all the institutes, the kernel masters, and all they do something like this. Within a matter of 2 days, you complete the session. So after that, we don't know the person whom we are engaging with. We don't care about the results. We don't care about the outcomes of what that person was able to get. So at the outset, what it will seem like to you, okay, I have learned a lot, but when you will basically try to do those things on your own, or when the need comes, when you want to apply those concepts, you will be totally blank. So I don't want you to get into that particular mode. I will be presenting this information in a very clear, crisp manner, where my goal will be you should be able to digest that information. So over here, I would like all of us to work as a team. When we work as a team, the outcome multiplies, the output multiplies. So that's why I want you guys to work as a team over here, and we all should reach the finish line. That's what my goal is, that's what my wish is. And on the WhatsApp, I would be active to help you out anytime. Okay, I would be very prompt on my WhatsApp. So that's why I would like to take you guys on a journey where we basically care about the results. Okay, so that's what is my goal to for each one of you guys. The intention with which you are joining this particular session, that should be achieved. Okay, and for that, I'm here to help you out. And what I need from you is a kind of commitment that you will not quit. Most of the times what happens when we start, we are very much high on energy to take up the new things. Slowly as the things become a bit complicated, we tend to give up. So I don't want any one of you to be in that category who gives up in between. Okay, so this particular program, the way I have designed, if you ask me, I have been conducting this training from last 9 years. 2014 was the first time when I launched this training program. And the kind of examples which you are going to see over here, it's going to be very different from what you would have seen, because it has come out of my creativity. And not only that, depending on the energy level which I see from you, I would basically deliver more than what I have committed. So you have seen the contents and you have joined this training program by looking into the content. But I promise you that if you are able to take up more and if you are able to show me that energy, I'm going to deliver more than that. I'm going to basically help you out more than that. And that has been the case because few of my past students like Sachin, Mohit, they are already the part of my other training programs. They know the kind of value which I deliver. So I don't care about the time. I don't care about you have paid me this much, I should just restrict it to sharing this much. What I care about is you should get the maximum possible benefit of your money and time. Okay, what intention you have come up with, come and join this particular training program. My 100% effort would be to help you achieve that, and I truly mean it from the bottom of my heart. What I need is basically your support so that you will not give up in between. Make sure that you complete the assignments on time. Okay, so it's not a course, it's a journey. And it's also about not provide it's not about providing the information where you feel overwhelmed with information, and at the outcome, when you look at the results, you're not at all confident of the concept. I don't want you to get in that kind of state. Another thing is, in order to get the best value of this training program, there are certain ground rules which I want you guys to follow. One of the thing is, attend all the sessions as far as possible. Try to make it live. Don't rely on recordings. Remember one thing, when you basically look into the recording, the energy level is basically drops down to 50%. Overall, if you ask me, it's just the exchange of energy. So when you are will be live, the exchange of energy would be maximum. So I want you basically to truly follow that. Another thing is, keep your cameras on. See, what happens is, the corporate culture has been such that where we are used to keep our cameras off. But remember, you are not into the corporate culture right now. Right now, you are here to achieve yourself, achieve something which you are passionate about, which you love about. And when you put on your cameras, you will naturally see that you will be more active, and the reception to the knowledge will increase. And I'm saying it from my experience, if you ask me. So earlier, long time back, I used to conduct the sessions like I used to keep my cameras off. So I used to conduct the trainings like this, sitting like this, sitting like this. So I couldn't see that energy, flow of energy. The moment I started putting the cameras on, and when I attend the sessions from my mentors, and when I keep my cameras on, I see the knowledge transfer increases by multifolds. So that's what my sincere request would be. If you are here to learn, if you want to learn, don't take it casually, and be 100% dedicated to this. I want to make sure that you should get the maximum possible benefit out of this session. Okay, so thank you very much for putting your cameras on. So whoever is not able to put, make sure that next time when you come, you are charged up and ready for it, putting the cameras on. See, when we see each other, right? Otherwise, what happens is, I feel like I'm just talking to some photos. Okay, I don't want that. I basically want to communicate with humans. Okay, whom who have some desires, who have some goals, who have some aspirations, and that's what basically I want to talk to. Not the photos. Okay, photos, they don't show the reactions. Names, whatever they are written, they don't show me the reactions. Okay, thank you very much, guys, for putting the cameras on. Others also, like whenever you are comfortable, you can put your cameras on, and you will see there will be a shift in energy. I promise you that. Okay, thank you very much, guys. Another thing is, keep it interactive. This particular session is not there where I will be keeping on speaking, speaking, speaking. Whenever you have any doubt, even slightest of doubt, don't hesitate. Even if you feel it's like a silly thing, don't worry. No one, no, everyone over here is here to learn. Even I am here to learn from you guys, from your questions. So don't hesitate. There is nothing like a silly question. When you will ask the questions, you will learn. I will also learn. So don't worry. I would be trying in best of my capacity to answer you that particular question in the best way possible. Okay, so keep it interactive. You are free to stop me, interrupt me at any point of time. Okay, there is nothing like one way communication where I would like you all to be muted and I will be keeping on speaking. That's not going to help anyone. I want this particular sessions to be very interactive and lively, where we are basically uh, each one of us is basically speaking with a high energy. Okay, all right. Another thing, be active in the community. You know, we have basically have the WhatsApp group. So WhatsApp group, look into the messages which others are sending. Learn from their mistakes. Many of time, what happens, we tend to ignore the WhatsApp messages, and we again ask the same kind of questions. So better you just look into what is going on in the conversation and you try to learn from that. That's the whole purpose of having a WhatsApp community, so that each and every one of you can share the knowledge, can share your doubts. I would be helping you out, and in case you know the things before me can help anyone, try to help your teammates. So work as a team. Another thing, complete all the assignments and on time. Please remember, this training minus assignments is nothing. Training minus assignments is nothing. Whatever live sessions you will be attending, and if you don't do the assignments, you would not get anything, not even the 10% of benefit. So I would basically help you out completing the assignments. Try to complete them on time. Okay, remember, one session in a week is not a big deal. Okay, you should be able to do it. Okay, and there are these are things are very very strategically designed, so don't ignore the assignments. And final thing, learn with fun. Keep calm, relaxed. Whatever is going to come your way, I'm going to present in a way which should make, which should be digestible and easily understandable. And if it is not, you can provide me the feedbacks. I'm open for the feedbacks. I will try to make it as simple as possible for you guys. So that's my commitment to you. So the ground rules which I told you is keeping your cameras on and complete your assignments, be interactive, be high on energy, so that you are able to receive the maximum possible benefit from this particular training program. Okay, so now this is the journey. This is how the journey looks like. Today, that is week number one, session number one. You should be clear about all the basics of the driver. You should have the bigger picture of the driver. By the end of this particular session, you should be comfortable in writing a very basic driver, and you will be provided some assignments with the help of which you would have worked with a driver. Okay, basically you should be able to load the driver, unload the driver, and all those kind of stuff. Week number two, we are basically going to focus on the character drivers. So remember, 80 percentage of the drivers which you have in the Linux kernel are the character drivers. So week number two will be the focus on the character drivers. Week number three, we will move forward, where we'll be moving on to the aspects of the Linux kernel, using which you can write a sophisticated driver, something like a kernel synchronization, mutex, semaphores, spin locks. How do I use it? So those concepts will be covered in the week number three. Now, after week number three, we'll be moving on to more sophisticated concepts, which we basically call it as a blocking a process. How do I basically block a process? So what do I mean by block? As clarified in the webinar, basically blocking a process is something like, let's say you are dealing with some UR and the process has requested for some data. Now, until the data comes from the UR, what you need to do, you basically need to put your process to the sleep. So how are you going to do that? How are you going to block the process till the data comes? And once the data comes, how are you going to wake it up? So all those concepts we'll be discussing in the waiting and blocking in the blocking a process session. So this is going to be very, very interesting if you ask me. Next, we'll be moving on to the kernel timing management. What is Jiffys? What are the kernel timers? How do you introduce a delay? How do you introduce a sleep? What are the possible ways? So all those things will be discussed in the kernel timing management. And week number six, we'll be focusing on the interrupt management, where we'll be discussing about the top half, bottom half. So overall, if you ask me, this particular training program is going to last at least for 1.5 months, where every week, Saturday 9 p.m., we'll be meeting up, and the overall agenda will be something like this. When we meet up 9 p.m., the first thing is we'll be performing the review of the assignments. Okay, we'll be handling the Q&As, we'll be performing the review of the assignments. After that, what we are going to do is I will prepare you for the challenge number 2, challenge for the upcoming week. So I will be explaining you all the concepts and everything, and I will be taking you to the challenge number 2. Again, subsequent week, review the previous assignments and basically move on to the next challenge. So overall, if you ask me, 1.5 months plus one classes or two classes more, it would be more, but it won't be less. Okay, so six challenges. So it would be 6 to 8 sessions, which you will, it can be seven, it can be eight. It depends. But the only thing which I want you from you guys is basically complete the assignments on time. I'm here to help you out. I'm here to support you wherever you are stuck. You just ask for the help. I will be helping you out. Okay, don't hesitate in asking. So this is how the plan looks like. So anyone having any questions, just let me know before we begin. Okay, all right, fantastic. So now let's begin. So yeah, this thing I already told. Now let's begin with a core session. So today, the objective. So let's keep the big picture in mind. What is the objective for today? The objective for today is basically to write a very basic driver. We should be able to write a first driver and we should be able to test on the board. Okay, that is what the goal is. So we will, all the fundamentals regarding the basics of the device drivers should be crystal clear today. That is the objective for today's session. So followed by this, there will be a couple of challenges which I would like to tell it again. These are very very simple challenges which I am giving you for the week number 1. You should be able to do it. You will have to set up the board and do all the things. So that's why week number 1 challenges are a bit simple. From week number 2, the complexity will increase. From week number 3, it will go even further. So make sure that you don't allow the assignments to be piled to be basically getting accumulated. Then what will happen is towards the end, towards the mid of this particular training program, you will give up. So do that don't do that. Be very very active and try to complete the assignments as soon as possible. Okay, and I will tell you one thing, if you don't do assignments, what will happen is when you come from the upcoming session, first half an hour to 45 minutes will be a waste for you because we'll be doing assignment review, and you might not be, even though you will be looking into, you might not be able to correlate. Another thing which is going to happen is the upcoming session, if it is connected to whatever is linked to whatever you have done previously, you will be again lost. So don't really take the assignments lightly. The heart of this training program is assignment, the challenge. Otherwise it's like, I would say, like, better to take the Udemy course on the device drivers and learn from there. But this, the level of this training is altogether different, believe me, it's altogether different. So that's why I'm telling everyone, like, during the first session, I want you guys to be crystal clear on the format of this training. Okay, you should be able to dedicate 2 to 4 hours in a week in order to catch up with this training. Okay, all right, so now let's begin with this particular session. Now, as I told you, most of the concepts you might have heard me saying from the webinars, and you might have seen me heard me saying it in the inner circle meetup, but I would again tell it for everybody's clarity. So now, first of all, what the driver is. So typically, see, whenever I ask anyone what the driver is, one of the question which I get all of the time is, driver is supposed to control some hardware. It is the interface between the application space and the hardware. But this is just partly true. This is not completely true, because the whole purpose of the driver is not just to control the hardware. There are n number of drivers available in your kernel which don't control any hardware. Say for example, there are algorithms which don't control any hardware, but still we basically call them as a drivers. So if you ask me, how do I define driver is a piece of software which drives, operates, monitors, controls something. Now that something can be another piece of software, let's say some algorithm, networking protocol stack. Still, we call it as a driver. File system, we still call it as a driver. It is an algorithm. So it can control another piece of software, or it can control another device. So when I basically control any device, I use the term device driver. Okay, I use the term device driver over there. So in a nutshell, what I would like to say is, every device driver is a driver, but every driver is not a device driver. Okay, let me repeat. Every driver is a every device driver is a driver, but every driver is not a device driver. So remember this thing, that driver can also be pure algorithm, like the file system driver. Like you have a ext2, ext3, ext4. All these things are drivers, but they don't control any hardware. They don't operate on any hardware. So the definition that driver is supposed to control the hardware is partly true. It's partly true. Okay, but even the mentors whom you will be going, they will give you the same definition. It is meant to control the hardware. That's a misconception. Just think from the big picture perspective, you will be very clear that that is not the case. Okay, now moving on to point number two. Why do we need the driver? So again, over here, I get the answers like hardware monitoring, security. These are actually the byproducts. Why do we actually need the driver? Think back to the OS. Why was this OS designed? How was this Unix designed? The Unix was basically designed to make sure that user space is not being troubled by the nitty gritties of the hardware. So one of the classic example which I typically give is, like you have a keyboard. So keyboard basically gives out scan code. Now keyboard is giving the scan code, so that means user space needs to take care of the scan code. Keyboard will give, say for example, xyz. So now the user space needs to know which scan code it is and how should I convert. We don't want that. Instead, I want this thing to be taken care by the driver. So no matter what kind of keyboard with what scan code you have connected, if a user presses A, the user space application should always receive the ASCII value of A. It should not even bother about which kind of keyboard it is. So that is why we need the driver. We need the driver to provide the abstraction, so that my user space application is not even aware of what is sitting underneath. So that is the level of abstraction we need, and that's why we need the device driver. So that, so now if you see, security and all is a byproduct. Security is a byproduct because you will be it's a driver where you are well known about the hardware is controlling it, not the application who doesn't knows about the thing. So that is the primary reason for having the driver. So now I will open up for the questions. If anyone has any questions, just let me know. Okay, so I hope this thing is clear to everyone. Fantastic. Okay. So now let's move on to the important topic of Linux driver ecosystem. Remember, whatever I am covering, this ecosystem is very, very important. And remember one thing which I keep on repeating all the time during my sessions is focus on big picture. Focus on things at the higher level. When you focus the things at the higher level, when you understand the things at the system level, they become much more easier. So all my sessions will be focused on the big picture. So try to basically grasp that thing. Don't try to grasp the APIs. Don't try to grasp those nitty gritty C code and all. That is there, that is important, but that can be always copy pasted. See, that can be always copy pasted. Even if when you will go for the interview, what will be checked is the big picture. Nobody will ask you, okay, you have written open it there, you should be released, you would have written this. No. Whenever I was appearing for the interview, I didn't used to remember any API. So basically interviewer was used to ask me, okay, you how you'll achieve it? Okay, this is the interface, this interface it will provide like this, here it should be this call and this will be called. Interviewer gets impressed. Okay, so never ever try to mug up the things. Just grasp the bigger picture, try to derive the things from the bigger picture. So my whole training will be always focused on the bigger picture, where you don't have to mug up the things. Once you understand the big picture, things should be automatically loaded, and then given any question, any situation, you should be able to correlate and understand the things. So that is how I want you to take this particular session. Okay, so now coming to the very important topic, which basically gives you the big picture of the Linux driver ecosystem. So now see what happens is, based on the OS specific interfaces the driver provides, in Linux, the driver is classified into three categories. What are these categories? One is basically the packet oriented or networking vertical, storage vertical, or we call it as a block oriented, character vertical, or we call it as a byte oriented. So interface which it provides, the minimal accessible unit which it provides, here it's a packet, here it's a block, here it is a byte. So there are three categories of the drivers which you have got over here. Now these three verticals, when you combine it with other two verticals, namely the memory vertical and the process management vertical, it gives you the complete textbook like definition of the Linux kernel, where OS is supposed to perform five management tasks. What are these? Process management, memory management, network management, storage management, and IO management. Now, these two things, though you can call them as a drivers, where processor and the memory are the respective devices, but for the reasons such as these being the core functionality of any kernel, take any OS, process management and memory management are the core functionalities of any kernel. And we touch these things only during the porting, when we are porting for the new architecture. So we typically don't write a driver for the processor. We typically don't write any driver for the memory. They are the core functionalities of kernel. And also, it is not possible to hot plug a driver for the processor or hot plug a driver for the memory management. So considering these things, though we can call them as a driver, we treat them as differently. So henceforth, whenever we discuss about the drivers, a driver will fall into one of these three categories. These memory management and the process management are the core functionality of any kernel. Hope it is making sense to everyone. Okay, so now let's dive a bit deeper into each of these layers. Now, if you ask me, your networking vertical is being split into two parts. Now, remember one thing, I will again give you the big picture. So, if you ask me, as you know, your Linux kernel is highly portable. Now, when you are basically designing a code which is highly portable, reusability is the key thing which you need to have. Key thing should be you should be able to reuse the code to the maximum possible extent. So, how do you reuse? Basically, factoring out the code which is common. That's how the Linux kernel is also designed. The common code, which is independent of the hardware, has been factored out. So, owing to this, what has happened is your networking vertical has been split into two parts. One is the hardware independent part, where you are dealing with a networking stack, where you basically slap the header, remove the header, which is independent of the hardware. No matter whatever hardware, say you are dealing the network interface card from the Intel, Realtek, or whatever may be the case, the criteria for adding the headers to the packet and removing the headers from the packet, processing the packets is going to remain the same. So that is where it comes like networking stack basically falls into the generic code. The layer beneath are the drivers which are specific to the hardware which you have. Let's say you have the hardware from the Intel, so you need the hardware specific drivers for that. Let's say you have the hardware from the Realtek, the hard Realtek specific driver would be there. So you see, this is how we have decoupled the common code from the hardware dependent code. And that thing you will find everywhere in the Linux kernel. Hope it is making sense to everyone. If anyone has any questions, let me know. Okay, so if this is clear, let's now move on to the second part of it. The storage vertical is again split into two parts. The hardware independent part, which is file system. So let me repeat for you what is file system. So just imagine, I'm going to basically give you very, very simple analogy over here. Not analogy in the sense like, let's say I want to achieve something. So many of you guys might not be clear about this stuff. So let me just make it clear what the file system is. Otherwise, it would look very complicated. So let's say this is my disk. Okay. And let's say this disk is basically split into 512 bytes of sector, 512 byte, 512 byte, 512
You
byte.
drawing something?
Yeah, you are able to see? No,
Now it
nothing is.
loaded. Okay. It's a bit slow.
Oh,
So
yeah, yeah. I think that can be my system's issue.
no problem.
Okay, is it visible this board to everyone?
It was visible for a moment, but not now.
Now it's not visible. Oh, okay, okay. Let me just close this guy.
Yeah,
I think it gets a bit loaded.
Visible now.
Visible? Okay, okay. So now let's say what you have got is you have got a disk which has basically this 512 byte sectors, and let's say I have files. Let's say I have one C file a.c. I have one image file b.img, and then I have other, say, some video file c.mp4, something like that. Okay, so now let's say a.c is like it's like basically filling into 1 KB.
Your display is not updating.
It's not updating. Okay, let me just close that. Okay, I will just close it and let me just again open it. Okay, something is wrong. Okay, I think something is going wrong with this. Okay, I will use other application. Okay. Mm, let me use this application. This is clear. Is this getting updated?
Yeah,
Okay. So let's say, let me again show you. I have A dot C, which is of 1 KB. I have B dot IMG. Let's say this one is of something like 50 KB. And I have C dot MP4, which is basically running into say 2 MB, something like that. Okay, so now this is my disk. This is my disk, and let's say it has these sectors 512 byte sectors. So this C code, let's say it's AD.C, it will occupy these two sectors. 50 KB, let's say it will occupy 10 sectors, around 10 sectors, right? No, it will be 512 bytes, and then we'll be needing into 10. Okay, some 100 sectors. It will be coming over here. So it will take up those things, and this will take two. So 20 MB. So we can compare some, say 200 or 300, whatever comes. So these sectors will be for A.C. This will be for B.img. This will be by C.mp4. So you have organized this particular thing. Now tomorrow, let's say the need arises that this A.C I want to update. And now the size of this A.C has increased from 1 KB to 1.5 KB. Now immediately after this, these three, whatever two sectors, you have your B, B.img, right? So now what should I do? Basically, one thing is move this whole B.img somewhere, but that's not a good idea. So rather than that, what I would like to do is whatever is towards the end, whichever is the free block, the part of this 512 byte, so A.C part 2, I will be storing here. Okay. So now when I need to retrieve, basically I need the algorithm which can tell me, okay, so you have basically two blocks over here, one sector over here. So you need to maintain the metadata for that. So now how do you maintain the metadata? So that is basically your algorithm. Okay. And let's say when the need arises to increase the size of the file, how you are going to manage that? Where you are going to locate the blocks, how you are going to manage these particular blocks or sectors related data. So you need the algorithm for that thing. Similarly, like let's say this particular B.img is deleted, how are you going to manage the free blocks, whatever blocks have been freed up, and how you are going to maintain that particular stuff? So that algorithm is what we call it as a file system. So your VFAT, ext2, ext4, they all do this particular stuff so that you can organize the data on the disk effectively and efficiently. You should be able to access it as fast as possible. Okay, so that's how the things are. Hope it is making sense to everyone. So you see, this is just the algorithm. Doesn't matter this algorithm you are using it on your pen drive or you are using it on your disk, hard disk. How does it matter to me? It doesn't really matter. So that's why your file system is independent of the hardware. Hope it is making sense.
Yes.
Okay, so that is what is the file system. So now you see this is the hardware independent part. What is hardware dependent? Block drivers. Now block drivers, what they are? Let's say I'm using an ID hard disk from this guy, the specific driver for that. Who knows what commands shall I send over the ID to this disk so that it can perform the write? Then what commands shall I send over the IDE to this particular disk so that I can get the data? That is basically your block driver, which cares about the hardware, which knows the details about the hardware. So that is how the things are. Okay. So whatever is the hardware specific part will go into the block driver. Now in block driver also there are two parts. See, there is a hardware independent thing So see, block related stuff, normally what operations you will be doing? You will be syncing the block, you will be reading the block. Then don't you need something like a caching mechanism? What do I mean by caching? Let's say some of the block is there which is just half filled, like it is just like out of total block only 2 bytes have been filled. Now I would not like to basically sync it onto the disk immediately. Rather than that, I would wait for that particular block to be filled so that I can optimize the performance. So all those algorithms are the part of the generic block layer. I hope it is making sense to everyone. So there is a generic block layer, then there is a block layer which deals with the hardware. So block layer is again internally split to the common code and the hardware specific part. Now another thing which I would like to say what block layer can do. Let's say you are dealing with a disk. Now as you know, your disks are basically slower. So now let's say at a time you got the 100 requests. So one is scattered here, one is scattered here, one is scattered here. So how do I basically queue it in a manner so that I can efficiently write one of those? So let's say I am writing the sector 10, and now I'm going to the sector 100, while in the middle I am on sector number 50, and in between the request comes right into sector number 10. Shall I go back and write, or I will come back and write it? So this is called elevator algorithm. So likewise you need some algorithms for the block driver, so that is being handled into the common block layer. Clear?
Okay.
Again, don't need to go too much into the details, but I wanted to give you the idea. Yeah, tell me, Hemteja, if you have question.
Can you give me an example for me to understand how block drivers are hardware dependent? Once again.
Yeah, yeah. So block drivers are hardware dependent. Let's say you have your Intel hard disk which is for the Intel. Now, Intel hard disk is basically designed in the manner which Intel understands. So you need to have a driver which understands this Intel hardware. That means what command should I send? How should I send this command? How should I format this command? This should be the responsibility of the Intel's driver. So now, if you take the Intel driver and you make it work on the Toshiba, it's not going to work because it won't understand those things. That is the hardware dependent part. Getting it?
Yeah.
It's like it's like that.
So this will be the same for the this SD card also. If I'm going to write the
Hmm.
data on SD card,
Okay, so now let me come to the other stuff. So now see over the period of time, what happened was you got the interfaces which are standard interfaces, like your SD card, SDIO interface. So then there was a protocol which was developed, which is a standard SDIO protocol, that which defines the commands and all those kind of things. So what people started doing is, vendors started doing, inside your SD card there is a firmware which basically understands your thing, and the external world it just shows the SDIO interface. And on the SDIO interface, what you are going to do is you are just going to send the generic set of commands because that is the standard protocol. So similarly, if you ask me, IDE, SATA and all, they are standard protocols which defines the standard commands. So in that case, what might be the hardware required? Hardware specific things required, probably like let's say I'm just going with the hypothetical example, like what specific sequence I require to reset this hardware. Anything specific needed for that hardware. So that thing you will be handling in the driver. But your most of the protocol stack is commonized. Hope you are getting my point, Rahul.
Uh, in this example, where does SDIO drivers fit in? Does those be part of block drivers or?
It is a block driver. SDIO is basically a block driver. So now what, over here, if you ask me, your all the SD cards typically follow the SDIO card. So that's why you don't need the SanDisk driver for SanDisk SD card. You don't require the Toshiba Toshiba driver for the Toshiba SD card. Why? Because it operates on the SDIO interface. And now in your card there is a firmware, okay, which shows up as a SDIO. Getting my point? So because of this standardization of the protocols, the specific drivers have become a common thing. So you don't need anything specific in your SD card. It remains same now.
So basically, you can say that the STIO drivers can be the generic part of block drivers.
Yes,
Okay.
exactly. I would say not SDIO driver, the SDIO protocol. See,
STIO.
SD. So now again, remember. So rather than going into detail, but let me just give you that big picture. See, now just think from the microcontroller perspective. Okay, from the microcontroller perspective, you will have your SOC. Okay, inside the SOC, you will have a. I will give you still simple example. You will have a
And I
SOC.
think we can say a Wi-Fi or a Bluetooth, I mean,
No, no,
irrespective of
that
whatever
will be
router.
too. No, no, that will be too complicated. Let me take a simple example. SOC, and let's say you have the UART. Now you see UART protocol is standard, but now UART registers which you are
Oh,
going
okay.
to write into, they are SOC specific. So you will write still a vendor specific UART driver for your controller, but this protocol is standardized. So what I mean to say is when I say SDIO controller over here, you will still need the driver for this SDIO controller. But SDIO protocol with which you have connected your SD card, that is standardized. Getting? That's what I mean. So one will be the SOC related stuff, one will be your generic protocol related stuff. Okay, so don't worry about all these things. Slowly, you will get into that. So now again coming back, so you have got the block drivers and the file system driver. Now we'll be having the drivers which are 80 percentage of the drivers. If you see, they fall into the character drivers vertical. So be it your sound, video, or be it your camera related stuff, be it your keyboard, be it your mouse, all of these things being byte oriented in nature, they fall under the character drivers category. Okay, so this character driver, as I have been telling, has been so vast that there has been a further split: TTY, input, video, sound, and like that. So there is a further subcategorization of this particular vertical over here. Okay, so our focus in this training will be this character driver vertical. So we'll be focusing on this, and using this character drivers, we'll be learning the kernel programming things. So now let's move on to other categories of drivers. That means we have not talked of the USB, we have not talked over here of something like a PCI. So where are those gone? So again, I give one very, I can say, common example. Let's say you visit a vendor and you tell him, give me the USB device. So the vendor will be confused. What vendor will think, what is this USB device? You will be asking, okay, whether you want the USB pen drive, whether you want the USB network dongle, whether you want the USB, whether you want the USB to serial converter, what exactly you are looking for. So what does it mean? There is nothing like a USB device. USB device without the functionality has no existence. USB is just the protocol. Similarly, PCI is just the protocol. There is nothing like a PCI device. When I say I2C device, does it have any definition? There, it can be I2C based RTC. It can be I2C based something like your what I can say, um, ADC. It can be I2C based E square prom. As such, there is no I2C device, right? It can be depending on the category. It can be depending on the functionality. I2C is just the protocol. So that's why these all drivers which are USB, PCI, I2C, they are horizontals. What do I mean by horizontals? They don't interact with the user space directly. They indeed leverage the facilities which are being provided by the existing verticals. So, for example, USB pen drive, underneath it's basically the USB packets it will be receiving. It will be again interacting with this layer to convert it into the block interface so that the same interface can be leveraged. So that means these are just the converters, packets converters. So USB packets are converting, coming, let me convert it into the block. So let's say USB to serial, USB packets are coming. Okay, let me convert it into the bytes. Whatever USB packets are coming, let me convert into the network so the networking vertical understands. So these are just the converters. Okay, whatever drivers you write over here. So that's why I call them as horizontals. That means they cut across. So giving you the example, let's say I say USB to serial, it will fall under this category. USB pen drive under this, USB dongle over here. So you see same like different USB device falling into different vertical, but underneath it will just receive the USB packets. Same thing is for the PCI as well. Making sense? Okay, so now coming to the final part of it, virtual file system. What is virtual file system? It's basically the one which realizes the concept of everything is file in a Linux. Everything basically in a Linux you treat it as a file. Slash dev SDA, that is a block device that is being shown as a file. How? With the help of VFS. Anything which you basically deal with your, say for example, USB to serial slash dev tty USB 0, that is again a device file. So who basically assists us in converting this information which is being redirected to the file to the corresponding driver? VFS. So the idea of everything is file is being realized with the help of virtual file system, or we call it as a virtual file system switch, whose job is to uniformly present a driver to the user space so that for the user space he should be able to use the common set of system calls open, read, write without bothering about what is there internally. That's what is the role of VFS. Okay, nothing to be complicated about. I have seen many of the guys get complicated by hearing the term VFS and all. Simple terminology, uniform access. Everything is the file concept is being realized with the help of VFS. And right now, these concepts might be still seeming a bit vague to you, but once you will be moving on to the character drivers, you will see it for yourself. In the upcoming session, we are going to see how do I create the character device, how do I create the device file, how VFS assist me in doing that. Then this concept will be more clear to you. Okay, so right now, if you don't understand much about the VFS, keep it aside, nothing to worry. In the upcoming session, the things will be more clear. Hope it is making sense. Yeah. So many things might seem like, okay, I'm dealing with the driver for the first time. It is like a complicated. Don't worry. You are with me. I will make sure and I will assure that you guys are crystal clear with all this stuff. Okay, so I'm here to help you out. The course is structured in such a way that each and everything is covered in such a detailed and a crisp manner that you won't be lost. And the examples are covered in such a way that they will make you feel okay, slowly, slowly, step by step, the concepts and dots are connecting. So be patient. Don't basically feel like, okay, I don't understand right now anything, what will happen. Don't worry. You just wait till the character drivers, things will be more clear. Okay. So now with that, let's move on. And now we are going to move on to the Linux kernel source code organization. So this concept also typically I cover it during my webinars, but here let me present it in a crystal and a clear manner to you guys. As you guys understand, this Linux was basically designed as the academic project. So what was the whole purpose of designing a Linux? The whole purpose was at that point of time, the students in the academics, they didn't have anything to practice with. They didn't have any OS with which they can practice. So Linus Torvald thought, let me have some OS with which hobbyists and students can play around with. So now he was himself a college student. So whatever he will learn from the book, he will basically apply those. So that is very, very simple criteria. So as per that, what he did is he created 5 different folders corresponding to the 5 functionalities. So what are the 5 functionalities? Process management, memory management, storage management, IO management, and the fifth component basically comes to us is memory. So, okay, let me recall: process management, memory management, storage management, IO management, and network management. So corresponding to that, he created 5 folders. So now let me show you those folders over here. So everything related to the processor you will find under the ARC folder. So if you see over here in the kernel source code, if I go, you will find one folder by name ARC. Here you are going to find Alpha, ARC, ARM64. So everything related to your processor specific code will be there in the ARC folder. Okay, so that's one part. But as you know, the process management involves 2 things. One is processor, managing the processor. Another thing is process management. That means how do I do the which task should be scheduled now? What algorithm should I follow? The real time algorithm or all those kind of things. So that thing you will find under kernel shed, where you will find various scheduling algorithms like you see RT scheduling and all those fair scheduling, you will be finding it over here. So your process management is again split into 2 parts. One is the processor dependent code and another one is the processor independent, which is basically algorithm. Now let's move on to the part number 2. You have the next important thing called memory management. For that, you have the folder by name MM. Okay, so now memory management, what it will be doing? All your mallocing related stuff, page table management, and all those kind of things. Now, what page tables to be managed and how to be managed? So, those again will fall into the arc. Okay, in the arc basically all the page table related stuff and everything will come there. So is a generic algorithm, like if the process is requesting for the memory, how should I manage it? So it's a generic thing which is covered here. Now another thing which you have got is the storage vertical. As you know, storage vertical consists of 2 parts: fs and block. So you will have a file system and the block. So fs you will find under fs, and you will find lot many algorithms over here, Minix, ext4, ext2, all those are NTFS, FAT, you will find over here. So all these are basically file system drivers. What about the block? As I told, block again is two layer. So this is basically a generic part, and under the drivers, say IDE, you will find the vendor specific things. Okay, vendor specific things. So let me repeat. You have FS, you have block, you have a drivers under which there will be IDE or MTD or something like that. So I'll again repeat, for process management, ARC and kernel shed. For storage management, FS, block and corresponding drivers under the drivers folder. For memory management, and corresponding details of those architecture related stuff again will come under ARC. Now comes the next part, network management, which you are going to find under net. Okay, this is generic part. How about specific parts? Drivers. So remember, in the network we have the two layers. One is the generic part, this is this one. Under the drivers, net, Ethernet, you will find Realtek, you will find Intel. These are hardware dependent drivers. This is hardware independent. Netlink, NetFilter, and all those kind of thing is hardware independent. Hope it is making sense to everyone. Anyone having any questions, just let me know. All right. So moving on to the next part, we have got the network, we have seen the storage and all those net we have seen. Under the drivers, I told you there will be a net which is available, and IO management, care, you'll sound, video, all those things will be there. And then you have a init where the initialization of the kernel is done. Kernel is basically kernel programmer's home. So now when you will be moving on to the kernel programming, you will be basically getting into the work queues. You will be looking into the wait queues. So kernel programming constructs you will find under kernel folder. Okay, and we will look into it later. Print K, kernel's printf, you will be finding in the kernel kernel folder. Then you have a lib IPC to manage the IPCs within the user space. Then you have a lib where the commonly used functions. So this concept will be more clear. Why do we require lib in a little while? We are going to discuss that. So just hold on to this lib. What does it contain? We'll discuss that. Then you have a include. Then you have other things, scripts, security, crypto, firmware, sound is over here. Under the drivers, there will be a video as well, which is again a character driver. Okay, so now with this much knowledge, let's now move on to the Linux kernel module. Now we are going to come to the part like what the Linux kernel module is. So remember one thing, driver we already saw. Driver is something, a piece of software which drives, monitors, operates something. Now, what is module? So I would say module is something which is hot pluggable driver. The driver which can be dynamically loaded and unloaded. That is what we call it as a module. So hot pluggable driver is what we call it as a module. The one which can be dynamically loaded and unloaded. Now, what really triggered the need for the module? What really triggered the need for the module? So, as you guys are aware, Linux is a monolithic kernel. What do I mean by monolithic kernel? The whole kernel runs as a single executable. Whole kernel runs as a single executable. So, for instance, when you will compile this kernel, what you are going to get is arc, arm, boot, zimage. So this is basically a single kernel, a single executable image. So now what does it means is your Linux kernel by default lacks the modularity. I want to test any driver. What I will do? I will open the kernel source code. Even if I change a single line of code, what I need to do? I need to compile the whole kernel. And then I need to basically reboot my system and do the stuff. Now just imagine during the development cycle, this is going to be a nightmare. Every time I just change a piece of code for testing, I just place it at the appropriate place, again reboot the system. This is very, very difficult. So what I need is I need the modularity where whatever piece of code which I want to take, I will create the loadable module out of that. I'll do the changes, I will test it without rebooting. I should be able to dynamically plug it in and plug it out. That is what is module, and that's why this terminology module. So remember, module is again a driver, but it's a hot pluggable driver. Okay, something which can be dynamically plugged in and plugged out. Okay, so hot plug and play driver, it can be loaded, unloaded dynamically. And why do we need it? Expediting the development cycle, providing the modularity to the Linux kernel, which was very badly needed. And standard modules you will be able to find under lib modules kernel version. So now if you see in your PCs, on your PCs, you will be able to see ls lib modules kernel. Okay, kernel version. So mine is 6.2. How do you figure out which kernel version you have? Uname hyphen r. Uname hyphen r. So it will give you which is the kernel version we are using. You go to the lib module 6.2, whatever the kernel you have, and inside that you will find a folder by name kernel, where you are going to find a directory structure which is very similar to your kernel source code. And here you are going to find all the drivers. Okay, all the modules. I will use the word all the modules. So you see, these modules are named with .ko extension. .ko. So let us see what all different .kos we have got over here. So is ext2, extfat is basically .ko, exfat, extended fat or something. So let me see fat msdos.ko. So whatever you will find as .ko, these are modules. Making sense? Now, from here, one thing is very clear that these are object files. Remember the C fundamentals. These are object files. Object files are not linked. Object files are not linked. Whenever you compile any file, you get the .o. From the .o, you get the executable when you link it. All right. So these are .os. That means they are not linked. So when will the linking happen? When you basically load them. When you basically will load it into the driver space, dynamic linking is going to happen. So that is where you will be able to execute it. So till you have not linked it, there might be some unresolved symbols in that driver. For instance, if we see, uh, let's say I want to look into this guy. Now, if I run the command over here by name nm, you see over here, u U means undefined symbols. The right now I don't know where are these placed. Where are these guys located? I'm right now not sure. Okay, so whatever you find U, those are undefined symbols. Now, after the linking stage, during the linking stage, this undefined symbols have to be resolved, and that is what is being done dynamically. So now I will show you that example which I was showing during the inner circle meetup call as well. If I do sudo ins mode of this particular driver, it basically, okay, it is already there. Since I already did that, I'll remove all the stuff. Okay, so all those things which are which whatever those drivers are did there, I'm just removing it. And now what I will be doing is I'll try to do inf mode of this guy. So what happens? This basically fails. It says there is an unknown symbol in the module. So now what I need to figure out is what are those unknown symbols. You need to type the message. That means I want to see the background messages. This is just the foreground message. Grab Rindis host. What it says, these are the messages. See, USB net. So these symbols are unresolved, and that is what I was showing you over here. If I look into NM, when I do the NM, USB net should be unresolved symbol. You see, USB net open is unresolved, undefined. That is what it is showing still. So that means till your symbols are resolved. So what happened when you did the irons mode, the dynamic linking kicked in the kernel. The dynamic linking kicked in, and it figured out, okay, this guy is looking for these symbols. I don't have those symbols, so that's why it immediately told unknown symbols in the module. I don't know how to handle it. Reject it. So now the question comes is from where you will find those symbols. So you will be finding those symbols from the in the kernel. Definitely it's not there. That's why it is cribbing. So it should come from somewhere else. So now this is what we call it as a module stacking, where you will be basically, let's say USB net. So if I want to do this thing again, USB net crypts, like I have some unknown symbols. So let me just figure out what unknown symbols this guy has. MII. So let me do one thing. I will basically go and load MII. This goes through. Silence means no issues. Okay. Silence means things are fine. Now let me put USB net. This guy is also silent. That means no issues. Now let me put Rindis host, which I was trying to put earlier. And let me see. Still, this guy says there are some symbols. So let me just figure out, okay, what symbols you want to look out for. It says something CDC or something. Okay, let me do the ins mode of that as well. Done. Renders host. Let me try to put it now. Done. Okay, this thing which I did, which basically we have seen, one module is dependent on the other module for its symbols. We basically call it as a module stacking. Okay, module stacking. So if you see ls mode, what we have seen here, MII is being used by USB net. USB net is being used by Redis host, and CDC Ether. CDC Ether is being used by Redis host. Now you see this guy Redis host is using functionalities from two modules. And this particular thing is called module stacking. Now likewise there can be some hundreds of dependencies. So how do we resolve it? If you ask me manually, it would be very difficult. So that's why we use the command called mod probe. So what will mod probe do? Let me show you. All the dependencies will be automatically figured out, and all the things will be loaded. So let me just remove all of this. So I will remove CDC Ether. So first I need to remove Redis host. Then will remove CDC Ether. Then I will remove the USB net. Okay. Now what I will do is sudo modprobe Redis host. Done. And you will notice in the ls mode, all these are loaded in one go. That's the beauty of modprobe. Okay, internally it will figure out the dependencies for you, and it will load all the dependent modules and things will be taken care. Okay, so now I have been speaking from long. If you guys have any questions, you just let me know. Hope things are clear. Okay, fantastic, Tushar. Good to hear that. All right, great then. So let's now move on. So module related commands, I have used most of them. You see, ls mode, ins mode to list the module, ls mode to list the modules, ins mode to load the modules, rm mode to remove the module, and then there is a mod probe which I have shown you. All right. So now we are coming to the important aspect of what it takes to write a driver. In order to write a driver, what do we need to take care of? Okay, so now in order to write a driver, first thing which you need to know is, one of the prerequisite which you need to know is kernel's C. Well, so with this, you might get a bit surprised. Do I need to learn new language? Like, what is kernel C? That means kernel C is different from the C which we have learned so far, or embedded C which we have got into. Don't worry, nothing like that. Kernel C is a pure C without user space libraries. Till now, you have been using the functions like strtalk. Kernel C doesn't have that. You have been using the functions like strcat. Kernel C doesn't have that because that is in the user space. So anything which comes from the user space, kernel doesn't uses it. So whatever sophisticated functions you have been using so far are not available in the kernel C. So now what you are left with? Pure C. While loop, for loop, all your keywords which C offers. Nothing more than that. No printf. Printf is not available. So when you are in the kernel programming, you have to boycott using the user space libraries. That is the precondition. You have to forget about the user space libraries when you are into the kernel space. So then you might be wondering how pathetic. That means if I want to do the strcmp, do I need to write my own strcmp function? Ideally, yes, since you don't have the libraries. But then you might be wondering how pathetic is this? Like all these basic functions I will go and write. This is what kernel developers also thought. So over the period of time, what did they do is all these functions, they all the commonly used functions, they created the library and they placed under the lib folder. So you remember in the kernel source code I showed you one folder by name lib. So all the commonly used functions, they are placed under the lib. So they might look like a user space, but they are not user space functions. They might be the one with a very limited functionality because they have been rewritten. They are not being taken from the user space libraries. So now the question might come, why didn't they take it from the user space? The reason is user space might have the hundreds of requirements which kernel is not bothered about. So it might be a full featured thing which kernel might not need it. And if I make my kernel dependent on the glibc which is coming from different organization, always there will be clashes. So I don't want to make my kernel dependent on somebody which is like an external community, can be some ego problem or something, but more fully it is something like I don't need all the functionality which is user space library is offering. I just want the basic minimal functionality. Why should I get dependent on this guy? Let me rewrite the things. So your kernel is a self-contained code. It is not dependent for its functionality on the user space. When you write the application, you are dependent on the printf, and that comes from the glibc. Kernel is not dependent on the glibc. Kernel has its own function called printk. Okay. So that is what the kernel C is. C without standard user space libraries and headers. Kernel source code is the another prerequisite you need to have because that is the library and it will have the prototypes. So for headers and libraries, libraries will be located in the kernel source code libs, which I have already shown you. I will show you again for the clarity. Under the lib folder, you will find all the commonly used functions. So you see string.c will be here, where you will find things like strcat being defined. So all the commonly used functions which you need to share, which you will be using in your day-to-day thing will be coming from here. So it is quite vast, though you get lots of stuff from this. Okay, so now another thing is kernel programming constructs. As I told you, you will be finding in a kernel folder. We'll discuss more about this kernel once we'll be moving on to kernel programming. And third requirement is, so you need the kernel C, you need the kernel source code which will have all the stuff, and you will need the kernel build system for building the driver. What do I mean by build system? Make file. scripts for configuring. So all those things you will be needing if you want to build the driver. So that's why if you ask me, you would have noticed in the course builder, whatever the LMS I have, one of the thing which I have asked you to do is over here to build the kernel. Okay, I missed that particular part or what? I will basically add it up. So you basically need to build the kernel. I'll add. Oh yeah, it's there, right? Configure and build the kernel. I thought, how come I forgot that stuff? Yeah. So that is one of the exercise which you need to do in to build the Linux kernel. And this is the kernel which you will be using while building your driver. Okay, because your current driver has to eventually run along with this kernel. So it has to be compiled using the build system of this particular kernel. So you need to follow these instructions and do the stuff. Okay, before I proceed, let me know anyone having any doubts here. So now let's get on to how does the driver looks like. Okay, so your driver looks a very simple thing. Okay, I'll just show you. One thing which you need to understand, again, a big picture and a very important thing. One of the thing which you will find in the kernel is the beauty of the kernel is though the whole code is written in C, but Linus Torvald is a big fan of OOPS. Okay, object oriented concepts. So throughout the kernel, you will notice that there will be many concepts which will be coinciding with OOPS because he has designed the kernel like that. So this is kernel is one of the beautiful example of writing the object oriented code using C. Okay, the way he has followed, the way he has structured the things, the way he has layered the things, it looks very beautifully organized like a C plus, or I can say oops, not C plus plus, oops. Now, one of the thing which you will find over here is typically what you have for any of the in the C, one of the thing which you have is like a class, and then you have a constructor, you have a destructor. So constructor gets called when you instantiate the object. Destructor gets called when the object goes out of scope, when you are destroying that object. So for us, when you do the inf mode of the driver, the constructor should get invoked. When you are doing a RM mode of the driver, the destructor should get invoked. So accordingly, the two important functions in the kernel are init module, exit module, or I will say cleanup module. Init module gets invoked when you do the inf mode. RM module gets invoked when you do the RM mode. Now remember, your driver in kernel can be a module or it can be statically compiled driver in the kernel. So now I want to ask you one question. Let's say your driver is integrated in the kernel. It's integrated in the kernel. So when will the init module get invoked? It's integrated in the kernel.
during the
Yes,
startup.
during the startup. Perfect. When your kernel is booting up, the init module will get invoked. What about the cleanup module? Yes, Lokesh, you are right during booting. What about the exit module? Shutdown.
Module when module is unloaded.
Sorry, Sachin?
When when module is unloaded.
Yes. No, no, no. That is about the module. I am saying when it is statically compiled. When it is statically compiled in the kernel. So when you shut down, typically. Okay, that's how it would be.
Yep.
Okay, so now this is how your driver in it looks like. That means module in it looks like. So you typically use the static. then you give the driver in it, you don't give any argument. If it succeed, it will give 0. If it doesn't succeed, you will return -1 out of this, -1 or whatever may be the error. So this looks very straightforward. Now you see, how do I register my function as a module init? For that, you have the macro called module init. To this, whatever function you will pass, that will become your constructor. That means in order to register it as a constructor, you need to use the module init. Now there is another thing. If you want, you can just name this function as a module init. That also will work. But typically we want to name our function as per the driver. So you can give any name, but you just pass that name as a module init over here. So that, okay, it's not module init module. If you name it as a init underscore module, that will be automatically that will be considered as a constructor. Okay, so this will get invoked when the driver is loaded. Now when the driver is basically unloaded, the drive module destructor will get invoked, which is basically named as a something like a driver exit. You register it using module exit. So now who is going to tell me? I think Sachin, you already know, is underscore underscore init. What is the significance of underscore underscore init over here?
Um, so you
Yes,
place it under a specific section.
yes, yes, right. And why do we place it under a specific section?
For once you're done with it, you can free up the memory.
Exactly, exactly, exactly. So see, there are certain things which will be required only during the initialization. Once we are done with the initialization, they are no longer needed. So what we can do is we basically remove it. So they will be placed in the special section, and you would have seen typically when the kernel boots up, at the end it gives freeing init memory. Freeing init memory is nothing but the memory which belongs to the init module needs to be freed up. So that is the optimization. If you don't use underscore underscore init, things will still work. But the thing is, you will be unnecessarily occupying the memory for something which will never be used during the lifetime now. Once the kernel is booted, it's no longer used. Then why should I basically keep it? I should throw it away. Making sense? So similarly, what is the purpose of underscore underscore exit? Anyone can correlate what is the purpose of underscore underscore exit?
Uh, this data is very much important. Don't delete it till end. I think what I can correlate.
Okay, okay, all right. So you just did told the reverse of what was in it. But the thing is, this is optimization. See, if you don't put this, anyways, the data is always going to remain. That is default. Okay.
Uh,
So now,
you don't
yes, yes.
free the memory until the shutdown.
Don't. Yes, yes. Your
You
point
don't
is correct.
free the memory, like don't clear the memory until the
Uh,
shutdown.
it's actually other way. It's actually other way. See, just think of it. What you will be doing in the exit module, what you will be doing typically in the, just think from the C++ perspective or something. In the constructor,
Release,
yes, go ahead.
you release the objects.
You release the objects, right? So basically, let's say you might have done some mallocing, you will be doing some freeing in the destructor. So now just imagine your system is going down. Your system is already getting shut down. At that point of time, does it really matters if I free up the memory or not? Because anyways the system is going down. It's shutting down. So what would I achieve by freeing up the memory? Nothing, right? So what I mean to say is, whenever your driver is statically compiled, you don't need exit module. You don't need exit module. Why? Because what I will be doing cleanup. My system is anyways going down. What kind of cleanup you are doing? I don't need that cleanup. So when you put underscore underscore exit and the driver is compiled statically into the kernel, this exit module will never be loaded into the memory. It will be discarded. But if it is a module, sorry, rather than module, I would say if it is a driver in the kernel statically compiled, then this never be loaded. But if you have compiled it as a module, then it's needed. If you remove the exit, what will happen? You can't do RM mode. You can't do RM mode because exit module is not there. So when you are having a driver as a module, exit module is must. But when you are having it statically and you have marked it as underscore underscore exit, it will never be loaded in the memory because we don't need it. Hope it is making sense.
Yeah.
Yeah.
Okay, so that's how is this optimization. So now let me show you one driver over here, the complete driver, how does it looks like. And this is basically the assignment for you guys. So what you need to do is you need to make this particular driver work. So sorry, not this, not this, this one. This is your driver. You see what it has got in it. Exit. When I do ins mode, this should be printed. When I do RM mode, this should be printed. And you see kernel's printf, print k, which basically prints this string. So can anyone tell me what is this?
I
Message level.
Which, sorry, come again.
Me- message level.
Message level. So this is basically the log level where you are saying that this particular message is just the information. So now remember one thing. See, you don't always want to clutter the screen with lots of information. Typically, what you want, debug messages should be put in a background. Only the critical messages should come in a foreground. So how do I handle it? So every log has the label. So info and all those things typically will go in a background. You will have to do demessage to see them. Critical emergency messages will basically come into the foreground directly. So there is a log label. So now I would like to give you one exercise where you basically need to make sure that even the info messages come on the screen. So kind of like what should I change in my log level so that I want to see even the debug messages on the screen. It should come. So what should I change over there? So just search for that. You should be able to find it. It's very easy. So making the log level threshold, changing the log level threshold in the sense all the messages, info, debug, irrespective, everything should be pushed onto screen. So what should I change in the, it is just one configuration thing which you need to change, and with that, that thing will be changing. So we'll discuss that in the upcoming session. Okay, so for timing, kern info is basically the info message. And now what we need to do is you need to compile that. But for compiling that, what you need to do? You need to open the make file. In the make file, this kernel source code path, you need to update it to the kernel which you will be compiling. Okay, as per the instructions over here, you need to compile the kernel source. So this whole path Okay, not sure why it is going slow. So this, wherever the kernel is compiled, you need to give the path to that over here. And now when you type make, this should generate first driver.ko. Okay, so this is your exercise number one for this session, assignment number one, where you need to test your driver. So of course, for testing the driver, you'll have to set up your board and you need to compile your kernel. So that is going to take its time. So that's perfectly fine. But by next week, make sure that these things are done. And the recording for this session will be available here. Whatever the session I have conducted today, it will be available here with you guys. Okay, so everything will be in a portal. Now what you need to do is, there will be a second assignment which I want you to take, where we are integrating the driver into the kernel. So this is a very interesting exercise. You complete it. In the upcoming session we will discuss on that, and in upcoming session we'll do the assignment reviews. We will discuss on this, and then we'll be moving on to the character drivers. Okay, so this is what is the end goal. So now I'm just going to show you the demonstration of how the things will work on the board. Okay, so on the board what you need to do, so on the board I'll boot up my board. So you will get the console for your board. Oh, I basically removed that stuff. I know. Give me a sec. So I'll just boot it up. So what you will be getting is, typically this is the serial console. All the instructions are there in the setup and all, nothing to worry. And whenever you have any questions, you can let me know. So this is my BeagleBone Black's screen console. And what we need to do is, we need to SCP this driver. So remember, you don't need any Ethernet cable over here. You don't need any Ethernet cable. All this USB is network is over the USB itself, the power cable. So you don't need to connect any Ethernet cable over here. So with this, what will happen is, it will prompt for password. You don't need to give any password. Then your board related this thing is transferred, and then you need to do ins mode first driver.ko. This should print mfd register. So now what happened, I got mfd register. This is the expected output. When I do rm mode first driver, remember one thing, when you do the rm mode, this ko typically should not be used. Why? Because .ko is a file name. You need to use the module name. So when I do rm mode, it should print mfd unregister. Once you have done that, your first assignment is done. Okay, and for the second assignment, instructions are there. You just complete that, and then we'll discuss in the upcoming session. Okay, so this week there's a bit of work which you guys need to do. Basically, you need to set up the board, and once your board is set up, your minicom is working, your USB Ethernet you are able to transfer, then you basically need to, driver is already there, you should be able to compile, you need to compile the kernel. That is one thing as per the instructions. Then you need to compile the driver, test it, and then do the second assignment. So you have a week's time for that, which should be good enough to complete all these things. If you need any support from my side, feel free and post it on the WhatsApp. Don't hesitate in posting your queries over the WhatsApp. I'm here to help you out, and whenever you are blocked, you just let me know. I will help you out and I will unblock you. Okay. The only thing is you need to be very open, and you should give your 100% to complete the assignment. And remember one thing, don't allow these assignments to accumulate, because then you will lose the motivation. I don't want anyone to go out of sync over here. Everybody, let's be on very much on like time with respect to assignments. Okay. And remember, this will be one of my slowest session where I'm conducting it for 1.5 months. Typically, I used to conduct 3 sessions in a week. Okay. But then I realized people are getting overwhelmed. So then I thought, let me reduce the pace. And that's why I basically care for your results. And what I expect from you guys is dedication and dedication to complete the assignments. Okay. So now before I complete and conclude this session, let me know if anyone has any questions.
Pradeep, I have one general doubt. So
Yes,
when I
please.
was trying to clone this, right? So it
Hmm.
was asking for GitHub password, and also, is there any specific
No, no,
account and
no.
password, or I can just sign in
You don't
GitHub
need to.
only?
You don't need to. Actually, there was a problem, right? I told you ELKI. I had a
Yeah.
typo over there. So after
Yeah.
LKI, it should not prompt for any password. It's an open repository. It's a public repository.
I did use LKI, but it was still asking for your password.
See, I will
I
show you
think
right
it's
away.
the password of your GitHub, or you might have created a app password. You know,
Typically,
GitHub
it should not.
recently changed.
See, I'll show you right now. Okay, I don't have anything set up, any key being added, so it should not prompt for any password as such. If it is a private repository, then it will prompt. Probably you might have. I don't know why this platform is a bit slowed down here. See, I will show you. I'm just using this, and it should go through like this. Just give this a try. I don't think any password is required. Unless there is some typo or something, password should not be needed. So it should work like this only. So still it's prompting from password. Just check from your end what might be wrong, because it's a public repository actually.
Okay.
So that should not be needed.
Pradeep,
Yes,
can
Rahul.
you can you explain, means can you give any other example why we are doing the KO files? So I'm still not getting any real time example.
Why we are creating? Why do you need the KO files?
Yeah.
Why do you need the KO files?
Hmm.
Uh, okay, let me still understand your question. You mean to say why do we need the modules?
Yeah, because we are touching the kernel space, so that's why.
Yeah, yeah. But thing is, see, real life example is pretty simple. I told you you need the modularity. How do I test the driver? if I want to test any functionality in the kernel, if I don't have the module, if I don't have the module, how would I test that? I will change the driver, I'll
Mhm.
recompile the kernel, I'll reboot the whole system. So now during the development, that would be nightmare, right? So that's why
Okay.
you need the modules. Okay.
Yeah,
So
but
now, yeah.
yeah, but in this case, the module means in the user space, what we are handling the application. So that may I'm still not more clear on my side Linux concept. So
Hmm.
as you told that in user space, we'll be having a driver and application
Yes.
handling. But now we are touching the kernel, and
Hmm.
if in some I2C communication or something comes up, in that
Hmm.
case, we are touching for the KO model, and then again recompiling or building that image or the kernel.
Hmm. Hmm.
So that I'm not getting a linking means, so because if something gets changed, then I will update my driver completely for the I2C driver.
Exactly. So driver you will update. Driver is a part of kernel. Driver is
Okay,
a part.
okay, driver is a part
Driver
of
is a part of kernel.
okay, and that's why we want to modify this.
We want to modularize it.
Okay, okay, got it.
Okay. So typically, so again to help you solve your problem again, like to help you understand better. See, typically what will happen is under the boot, you will have something called VM Linux. This is your kernel image.
Mhm.
Okay. So now when you reboot, now whatever the kernel is running, this is the executable for that. Okay. So now what you need to do is, if you want to make any changes, you need to compile your kernel and you need to change this VM Linux. Now changing this VM Linux is just the executable, right? So it won't come into picture right away because it is just the executable file on the disk. When it will
Mm.
be run? When you reboot it.
Yeah,
Getting it?
yeah.
I hope it is clear now.
Yeah, yeah, yeah.
So
Thanks.
this nightmare we want to avoid. Okay, so that's one part from the development perspective. But now you see my x86 PC has so many modules. Why is it so? Are these all like a development drivers? No. Then why still I have in my module in my production system? The reason is this particular kernel is generic. Now you never know which hardware is there on my PC. This PC can be from the HP, it can be from the Toshiba, or it can be from any other guy. How do I know what all different hardwares are there? So you dynamically detect the hardware during the boot up and then you load them. That's why you need the modules here because your system is not known. So now what drivers shall I integrate? If I integrate a whole lot of drivers in my kernel image will run into GBs. I don't want that. Instead, I just want my basic minimal kernel image. Depending on what hardware I have, I load it on the need basis. For example, right now there is no USB pen drive. Why should I load the driver for VFAT when I don't need it? So on the need basis, I will load them. That is another usage of the module. Like
Mm.
use it on the need basis, on demand basis. Clear?
Yeah, yeah. Thank you.
Okay, no problem. Okay. All right, so we'll close the session over here, guys. Thank you very much, and I hope you enjoyed this particular session. And every week we'll be having this value-packed kind of session. Just make sure that you are on track with respect to assignments. Once you lose the track, I will tell you, you will lose interest from this training program. So don't do that. You are here to learn something, so make sure that you achieve that. Okay. So good night, everyone. Thank you very much, guys. And see you next Saturday again at 9 p.m. Bye bye.